A system of n non-interacting classical particles of mass m is in a two-dimensional harmonic potential of the form given here. Alpha is the just a constant, a positive constant. The canonical partition function for a system at temperature T is what? So we know that the partition function's formula z of n is given by e to the power of minus beta. So actually let me write only z. Okay, so z of one particle, partition function of one particle. In the end we'll find out z of n, which is the partition function for n particles. So e times beta e dq dp, and e is nothing but the energy, total energy, p square by 2m, and the potential. So it's the Hamiltonian. So we have we just substitute this here in this equation and try to integrate and get the result. So what we would do is we just substitute this value of e in this equation, and our integral, and for so this is a two-dimensional problem. So dq is nothing but dx dy and dpx dpy. So this is the integral that you have to evaluate, minus infinity to infinity e power minus beta p square by 2m plus alpha x square plus y square dx dy dpx. So four integrals are there altogether, and this can be split and written as four integrals separately. So e power minus beta, so px, the component, only the x component of the momentum, integrated with the respect to the x component, and e to the power minus beta py square. So the y component integrated with respect to the y component, and then we have the position, so integration with respect to x, and then we have integration with respect to y. So this just becomes actually, so we use some standard integrals to evaluate this integral. So this just becomes so this is minus infinity to infinity, and all the limits are going from minus infinity to infinity. So an integral like this, e to the power of minus some constant, whatever it is, so let's say take beta alpha x square dx integrated with respect to minus infinity to infinity, gives us, it's a standard integral, gives us pi by whatever is the coefficient of x here, whatever is the coefficient of the x square term, so which is nothing but beta alpha here. So here the coefficient terms for px square is nothing but beta by 2m. So here also is beta by 2m. So therefore what we get is, so you just evaluate this integral using this formula, the standard integral formula, check that you get 2m y square by alpha beta square. So that is what you should get. Okay, so just check that. So this is the partition function for one particle. Okay, so one particle. So for n particles, this will be raised to the power of n. Okay, so this will be raised to the power of n. So this is your answer. So the right option for this question is given by the option D.